So.
Okay. I mean, yeah, I guess for is the recording people watch it afterwards, they would want to see the slides or something, right? Like will this?
Yeah, so it will.
Okay, yeah, that's good then. Well, hey guys, nice to meet you all. Yeah, happy to be here to kind of help out, doing a bit of an introduction to some blockchain analytics concepts. Background on me, my name's Kofi. I was, up until recently, I was a partner at an early stage crypto VC called One Confirmation. One Confirmation is best known for leading the seed rounds of some of the the market leaders in the space today, like OpenSea, which is the largest NFT marketplace, Nexus Mutual, which is the largest insurance provider in DeFi at the moment, and Hop, which is the most popular L1 to L2 bridge. And yeah, in my kind of role at One Confirmation, even before that, definitely use blockchain analytics tools like Dune a lot, whether that's in due diligence or kind of researching different categories. So it's a pretty useful skill to have, you know. You guys are kind of doing a really good job of trying to jump on that early. So today we're going to talk a bit about decentralized exchanges, and we're also going to look at some equal concepts that will be useful for looking at different on-chain data problems that you might be interested in. So I think that probably in the previous sessions, you guys have already started looking at Dune Analytics, right? Yeah. Well, Dune's great because Dune basically does the work of running nodes for a bunch of different blockchains and pulling raw data from them. So if you're running a node for Ethereum or Avalanche or Solana or whatever it is, you can pull directly from the node transaction data, log data. Logs are basically anytime a smart contract emits an event. So you've got a smart contract for a token like USDC and somebody makes a transfer. Anytime an event like that happens, a log is recorded on the blockchain. You know, transaction is anytime somebody is kind of making some transaction that interacts with a smart contract, all of that gets recorded. So there's all this raw data, right? But the problem is that if you're writing queries, it's just harder to audit, harder to read, harder to understand if you're looking at a query that is just trying to do everything from raw data. So Dune does a great job of making these decoded tables, which is basically like, well, instead of you kind of filtering through the logs for, okay, these are the logs for this contract where this data was involved or whatever, let's just decode it for you so that you can have a very kind of simple to look at abstraction of these are all the events that happened with this smart contract. So OpenSea's Seaport contract, you know, anytime there was a sale event, like this is just a table of those sale events or a table of these were the contract calls that were made. It's a lot easier to understand. And you'll see that the more that you play around with Dune. So decoded events and calls are like a level of abstraction above raw data. And then, you know, further above that, you've got these Dune spells that are basically, I mean, spells are really the same as queries. But what somebody has done is that somebody's made like a very complex query for you, and that's stored in the backend, so you can just build on top of it. So instead of you recreating the work of, you know, making a query that pulls all the sales from all of the NFT marketplaces or whatever, Dune has NFT trades. So, you know, Dune wizards who kind of contribute to that open source repository of spells have already done all of the work of compiling sales from all of the different NFT marketplaces. And you can just answer your questions on top of that of like, let's take a look at monthly aggregated sales across all marketplaces. It just saves you time. So yeah, it's really useful stuff. So decentralized exchanges, how many of you have used a centralized exchange? Like how many of you have used Coinbase or Binance or something along those lines? Kind of show of hands. Yeah, okay, cool. Well, good number of people. So yeah, I mean, you're kind of familiar with how on a centralized exchange, you can buy crypto with your bank card, you can buy Ethereum or Bitcoin or whatever it is. Decentralized exchanges are different because it's not a company. Well, I mean, there's a company involved, but it's not a company. There's just a smart contract on chain that does all of the work of allowing you to trade tokens with other people, peer to peer. So you can buy any, what's the word? You can buy any ERC20 token using any other ERC20 token on a decentralized exchange without having to trust like an intermediary or a third party. And they're a really big part of the ecosystem. Basically, how they work is that each pool, so let's say that there's a pool that allows you to trade between ETH and USDC. Each pool is a separate smart contract that has some amount of, in that case, ETH and USDC in it so that people can trade between them. And how that money gets there is that anybody can be a liquidity provider for these pools. So you can say, I'm going to provide liquidity for the trading of ETH and USDC on this decentralized exchange. And the reason why you do that is because you earn the right to earn some of the trading fees. So right now, on Coinbase or whatever it is, you can't participate in providing liquidity and you can't earn Coinbase trading fees. Of course, all of those trading fees go to Coinbase. On a decentralized exchange, you get to actually be part of the magic, kind of, right? Which is a cool thing. Yeah, whenever you provide liquidity, you get minted an LP token that represents your ownership of that share of the liquidity. And it's a very neat little magic trick that we managed to figure out. So Uniswap is the most popular decentralized exchange at the minute. They do just as much trading volume as a centralized exchange like Coinbase. And how the second version of Uniswap worked is that each pool, like I said, is a smart contract of its own that allows you to trade between the two tokens in the pool. And the tokens are priced on a bonding curve. We've got this very simple, it's like not crazy math at all. It's just X by Y is equal to K, where X is how much of token 1 the pool holds, and Y is how much of token 2 the pool holds. So if it's ETH USDC, you've got 1,000 ETH and 1,000 USDC, that would be the X and Y. K is a constant. And using that model, you can kind of see how the more of one token you buy, the more expensive it becomes in relative to the other token, and vice versa. And this allows us to kind of automate away market makers and kind of all of the other processes that are involved in the centralized exchange. The new version of Uniswap, Uniswap v3, has concentrated liquidity. So before you would just provide liquidity, like provide your amount of these tokens, and people would be trading all along the curve, and you'd be a part of that. With concentrated liquidity, you can say, I only want to provide liquidity between these two price points. So if it's ETH USDC, kind of going back to that example, you can say, I only want to provide liquidity for trading between the price of $1,500 ETH and $2,000 ETH. And if the price of ETH falls outside of that range, I won't be providing liquidity, I won't earn trading fees or whatever. You can kind of really set more specific parameters there. And I mean, there are a number of reasons why this is interesting. It just kind of makes things more efficient. It means that you can provide a lot of liquidity at the point where like most of the trading is happening, and not like have as much liquidity on the edges. Like it doesn't really make sense to be providing liquidity at $5 ETH because ETH isn't going to be $5, or at least if it is, I'm fucked, right? But yeah, there's just like prices where it doesn't really make sense to be providing liquidity. You can just focus in all of the money where it's actually useful. Some more detail on how Uniswap works. So Uniswap has a set of smart contracts it runs on. Kind of most important ones are the factory contract. like I was mentioning, each trading pair, whether that's DAI, USDC, or ETH against Maker token or whatever it is, each of these pools is a separate contract, and the factory contract is what actually generates all of those pool contracts. So everything kind of stems from it, right? Each pool contract has the same functionality of, there's a function that lets you do a swap between the two tokens. There's a function that you can call to check the reserves of either of those tokens. It's all standardized. And, the kind of other important type of contract in the mix is the ERC20 token. So ERC20 is a standard. Pretty much all the fungible tokens on the Ethereum blockchain and most EVM type blockchains follow this standard. And the standard just sets out a bunch of consistent functions that everybody has. So everybody has a function for transferring tokens. Everybody has a function for checking the balance of, how much of this token does a certain address own. And it's good to have a standard because it means that protocols like Uniswap can basically deal with any token. Like all of these tokens work pretty much the same, so our code works for pretty much any token. And it just kind of is good to standardize things for that reason, because then you can have composability, you can build on top of each other. So yeah, this was kind of some of the stuff I was talking about before in terms of there's just functions that each of these smart contracts have. So smart contract is just a program like any other program. It has functions that you can call. Every pair contract has a swap function for you to swap between tokens. The factory contract for Uniswap has a create pair function that you can call to create a new pair, to create a new pool, and kind of so on and so forth. And yeah, kind of going back to talking about the decoded tables, instead of looking at raw blockchain data, you can give Dune a contract and get it decoded so that you can get a pretty easy to understand table of all of the events, all of the contract calls for a specific contract. So for Uniswap 3, you can search it in Dune, and you'll be able to find, for instance, for the factory contract, here's a table of all of the times a pool was created, the pool creation event. And for that event, there's some data involved, like, yeah, we made a pool, but what were the tokens in the pool? And, what was the time that this happened? And what was the fee that we set? You can see all of those events. You can see all of the data involved there. So kind of the first bit of SQL we're going to look at right now is using one of these decoded tables. We're specifically going to look at, like I was talking about, the table for the Uniswap V3 factory contract, the event where a new pool was created. We can use that table to answer a question like, what's the most common token involved in a pool creation? So we made all these pools, and each of these pools has 2 tokens. What's the most common token out of all of those pools? We just kind of got all sorts of queries here. Comment them out for now. And just look at this first one. So it's a pretty simple query of just looking at, for this particular table, kind of the pool created event, you'll have a token 1 and a token 2. So we're going to, for all of those variables of token 1, count how many times they show up. So in how many of these events did each of these tokens show up? You can just count that. You can run that query. Oh, hopefully it's not going to be slow. Duna's been having some pretty interesting upgrades over the course of the past 2 weeks, but that has also meant that there have been a few days where everything has not moved as fast as I would like. We'll give that a minute. Hopefully, oh, there we go. So here we can see the top 10 tokens that showed up the most often if you look at all of the events where pools were created. I don't actually know which token this is, but we can just go to Etherscan. And we can check what that So this is the token for wrapped ETH, which makes a lot of sense. And yeah, that's kind of a very simple question that we can answer. Now, another way to do this same query is that we can use a window function. What's a good way to describe a window function? Basically, you can make a query like a sum or an average or a count over a specific window of rows. So in this case, we're going to use a window function that counts all of the occasions over the window of a token. I'm not explaining this very well, I'm rambling a bit, but let's say that you divide the data set into, here are all of these windows for each token. So here's the window of all of the events for USDC, a window of all of the events that contained wrapped ETH or whatever. Let's do a count over each of those windows to see how big each window is. Probably a better way of explaining that, but I don't know. W3 schools or something will have a much better explanation of window functions than I will. But yeah, we can run this query as well. And like you see, we get pretty much the same result of getting a count of how many times these tokens showed up in the whole history of pools being created on Uniswap. And it just looks a little cleaner than our first example. Oh, yeah. So this was kind of a bit of what I was talking about earlier. When you use a window function, you're doing a calculation over a set of table rows that are related in some way. So in this case, we are looking at doing a calculation of a set of rows that were related by, they had the same token one. And yeah, it's just an alternative to using group by to do a calculation over some data set. And it's interesting for a few examples that we'll be looking at later on. The way that it's usually structured is when you do a window function, like the one that we looked at before, just so that you don't forget, it's structured as what is the function. So it could be average, count, sum, whatever it is, over partition by what is the partition group. In this case, the partition group was tokens. We were segmenting the rows by, groups of what token was in that row. And then you can do an order by as well. So that's, usually how you write these things out. This is kind of order of execution. So, when you run a SQL query, some parts of the query are executed before other parts of the query. And, that's kind of where window functions fit into the order of what will actually get executed when you run a SQL query. You don't really need to worry about that much for simple stuff, but becomes interesting later. Another kind of useful concept in SQL for when you're looking at blockchain data is subqueries, because I guess a good way to explain it is that sometimes you want to make a temporary table and then extract an insight from that temporary table, as opposed to making a really, really long query. I mean, sometimes you don't even have that option if it's something really complicated. So the subquery, you can say, okay, I'm going to make this table of, for instance, here are tokens and how many times they showed up in Uniswap events. And then that's a temporary table. I'm going to make a new query on top of that. That's what you would use a subquery for. So in this example right here, let me comment this out real quick. In this example right here, we've already kind of done a query that we looked at before for looking at different tokens, how many times they showed up in the history of pools being created on Uniswap. That's been made a subquery. It's in brackets. and we're making a new query on top of that. So we're going to say, give us all of the rows, all of the columns from that subquery table, and let's make a new column that's a ranking. So it will just be a ranking like first, second, third of, who was the biggest, who was the #1 token, who was the #2 token, that sort of thing. So we can try and run that. It will hopefully only take a few seconds. So you can kind of see there, one thing I didn't mention. This is using a function called rank, which you may or may not have seen before. You'll basically get a ranking, like I was saying, who's first, second, third, over, one column that you're looking at. So this is a ranking by the column we made before of how many times token 1 showed up, and it's ordered by descending. So the biggest will be rank 1, second biggest will be rank 2, and all of that good stuff. This might take a second. And there's also kind of an interesting thing of you've got rank here, and we've got another version of this where we use dense rank. The difference between rank and dense rank in SQL is that in this case, we're trying to rank by the number of times a token showed up, right? But what happens if there are 2 tokens that both showed up 10 times? With regular rank, like if 2 tokens showed up 10 times, it would just keep going. It would be like, oh, this was ranking #5 and this was ranking #6, even though they have the same amount of times they showed up. Dense rank, I'm pretty sure, will do a thing where if there's a tie, they'll just have the same ranking. So if in that example, the 2 tokens both showed up 10 times, they'll both be rank 10, as opposed to showing up in different ranks. Did I get that right? Oh, it's the other way around. Sorry. Yeah, so it's rather with, if you use rank, they'll be tied for rank. So, these 2 tokens both showed up 15 times, and so they're both rank 10. It's a bit weird. But if you use dense rank, I think it will not do that. It will, what's the word? Just create a new ranking. But yeah, let's head back to the slides for a second. Yeah, we talked about that. And so, there's an exercise we can do now where we can write a query that will rank token holders. So Dune's got a nice table that kind of aggregates for all ERC20 tokens. So for all the fungible tokens on the Ethereum blockchain, whether it's DAI or the Maker token or the Uni token or whatever it is, all of the transfers for all of those tokens in all time, which is a really useful table. So we can create a common table expression. Good way to describe that is that before we made a subquery, which is like a temporary table that you're building on top of, a CT is just another way of doing that. It's easier to read, it's cleaner. Subqueries are faster execution-wise, but if you make a bunch of subqueries, it gets really messy just to have a bunch of Russian dolls nested. With CTs, you'll be able to see it when we look at the example. It just looks a lot better. We'll make a common table expression, so a temporary table of all of the transfers of a particular token, and then we'll make another subquery that will be what is the balance. So how, based on the transfers, we can say, well, these tokens were transferred inside of these wallets and out of these wallets. So what's the remaining balance in everybody's wallets right now? Can make a query for that, and we can finally make a query that will rank wallets by who's the biggest token holder of that particular token. So we'll go through that exercise and take a look. That would be this right here, I'm sure. Yeah, uncomment some of this stuff and we'll look at it in depth. Yeah. So with a common table expression, it's different from a subquery. You saw before when we were looking at subqueries that you're basically doing your select table names from, and inside of the from argument is just inside of brackets is your other query. With the CTE, you declare it differently. So you give it a name. In this case, I'm making a temporary table called transfers. And you start off saying with transfers as, and in that bracket, you'll write your temporary query. What this query is basically doing is that it's looking at, from this table of all of the transfers that have ever been made of ERC20 tokens, what was the transaction hash? What was the, in this case, the address that was sending the token? And we're going to do negative value in terms of, the value is how much of the token was sent. Basically, what we want to know is, in this case, if the address was the from address, it was sending a token out, so we're going to reduce its balance. We're going to reduce our count of how much of this token it holds. And there's another query that's, where an address is to, so in that case, sending a token from to another wallet. If it's to, it's receiving some ERC20, some amount of that, and we won't multiply that value by negative in this case because its balance should be going up. These are two queries that we're combining with a union. So how union in SQL works is that we've got two tables that have the same number of columns, well, yeah, same number and type of columns. You can just smash them together and make one table. So this will create one big table that has all of these addresses, events where they were sending a token out and the negative balance, and events where they were receiving a token and the positive balance that was added. That will be one query in this set. We're making another CTE, so this comma, we're giving it another name. This is going to be the query for calculating the balance. So how much of each token does each wallet have? And it's very simple. It builds on the first query that we wrote, the first temporary table that we wrote. It's basically saying, well, we've got all of these things where for an address, some value was going out or some value was going in. Let's sum it up so we know how much of that token that address holds now. That would be its balance. And yeah, so we've done all that work. We've made two different queries, and we can finally make the query that we actually want to make, which is, for each of these addresses and their balances, give it a ranking, make that a subquery. Make that a subquery so that we then pull everything from there that's in the top 10. So yeah, we'll give that a go, and that should be fine. It's queued right now. Probably should have signed in with my account. Dune's doing a weird thing now where they're transitioning to a new payment plan. So if you pay more, you can get fast execution, but the free tier is always going to be free, and it's always still going to be super useful, like having access to like this wealth of abstractions and queries that other analysts have made, and all of this historical blockchain data, and getting it for free is a pretty sweet deal. Even if on the free version, it means you're gonna have to wait a bit sometimes so that, yeah, folk above you can get their queries executed first. That will take a second, and just take a look at these. Pass these slides. Is there anything else that was interesting in here? Not really. You take a second. Oh, the keys up. Also waiting for that. I actually should have asked this before. Does anybody have any questions? I've been talking a lot, but I haven't really. Yeah, go ahead.
So you said that Uniswap is the biggest DEX and uses automated night market traders. Are there any DEXs that use order book or some other kinds of mechanisms to determine the price?
Yeah, that's a good question. So I mean, so, for anyone who's not familiar, on kind of regular centralized exchanges, usually how the price of something is determined is an order book. And actually, the first decentralized exchange on Ethereum, Ether Delta, used an order book back in the day. It had a really, really bad user experience. It was not good. AMMs are, I mean, if you're doing stuff on chain, AMMs are just a better solution for a number of reasons. Kind of like right now, it's one of those things where it's just kind of an AMM contract is just more efficient than anything that would use an order book on chain. And there are some projects right now that are trying to, create like whole new blockchains that are just dedicated to being efficient for order books. But yeah, there's like a lot of really interesting literature on why AMMs won out. I'd probably kind of do a bad job of trying to summarize it all right now, but they're the leading solution at the moment. But yeah, people have tried, the short answer is that people have tried it before, and people are trying it now, but AMMs are still kind of the most popular solution at the moment. Yeah, this is taking a minute to run, so you can, but there's kind of a general impression of how you would do balances type query. We can look at some other stuff while we wait. So, go ahead. Yeah.
How is this different from the Kaggle one, the Google BigQuery?
Yeah, so I mean that's interesting. I know that Google does have a BigQuery for Ethereum data. The difference is that I think that just provides only raw data. I'm pretty sure. Could be wrong. So I mean, you can get really, really fast queries on that in terms of if you were just looking at raw transaction data, raw logs, raw traces. But Dune's a lot simpler to use because it's got these decoded tables of here's just a table of the events for a particular contract, or here are abstractions that other people have made, such as dex.trades, which is abstraction for all of the trades that have been made on every DEX, just kind of all in one place. It saves you a lot of trouble. It would take a really, really long time for you to write that query yourself.
Actually, on BigQuery, you can download the blockchain ETL dataset. The co-founder Nancy created, and you can find decoded events and you can actually submit contracts. So you can't find the spells or abstractions that you make, basically. That's how you make.
Yeah, didn't know that. But yeah, so I mean, it seems that there is a way to get to make decoded tables with that. But yeah, you'd probably still use Dune because the spells are really useful. Like in this case, there's a simple query there that allows you to pull all the trades from dex.trades where the decentralized exchange used was this aggregator called 1inch in the past day. And that's like super simple. That's just 3 lines. But if you wanted to kind of write your own query using decoded tables to kind of get all the trades from 1inch over the past day, it would be a lot more trouble than this. That's one thing that Dune's really good for.
Is the free version able to carry like historical data for research, or if for research we have to?
Yeah, I mean, yeah, so right now, this is the free version, I'm pretty sure. So yeah, you have access to all the same data anybody else has, all of the data from the beginning of time, all the tables. The only difference with paying is that your queries will run faster, so you don't need to wait 6 minutes or however long we've been waiting for this to run. You just get better compute. And there's also some stuff around paid plans. You can make private queries and stuff, which is good for, I don't know, if you have some alpha, some like secret source that you don't want other people to know. You don't want it to be open source. You could do some private stuff there if you had a paid plan. This one.
Is the principle to build this database just using the same Ethereum ETL or Web3 Python? Like how do analytics then stuff with this?
Yeah, so I mean, how Dune works in the back end, I know all the details of this, but the high level overview is that they're personally kind of running nodes for all of the different blockchains that they index, whether that's Ethereum or Solana, Avalanche or whatever. And then they're pulling all of the raw blockchain data that they get from those nodes into I think the database uses Spark. And, then there's like a lot of, probably caching solutions and pipelines and other stuff that I have no idea about that then allows us to use the tool to make any sort of queries that we'd want to make. And yeah, it's just a really awesome, useful free service that you can pay for if you want to pay for, if you want to do kind of more advanced stuff. So this was the query I was talking about, selecting everything from dex.trades, where the exchange used was, in this case, 1inch instead of Uniswap in the past day. So, I mean, this is awesome. I mean, if you use Coinbase or Binance or something, there's no way of you knowing, like, what did people trade today and who traded and how much did they trade. But on the blockchain, everything's open. We can see that whoever this is, trader A, did a trade from ETH to DAI stablecoin, and they traded, 0.56 ETH, and they got 639 DAI, and this happened on 1inch, which is an aggregator. So the trade didn't actually happen on 1inch. It aggregates a bunch of different DEXs. The trade actually happened on Uniswap V2. We can see exactly when that happened. Full transparency over like all of these really interesting financial things that happened over time. And yeah, it's simple because of spells. So that's kind of a useful little thing that we've got going on right there.
That's cool.
Yeah.
So just for the infrared the free version limits the function every day. If we use a free nodes from Alchemy, QuickNode, infrared, we can't carry too many. Yeah,
like you're totally right. Alchemy and Infura are, kind of good for if you want to get raw data right now, super fast. Alchemy is better than Infura for that. But yeah, that's what they're good for. If you want to look at all of this historical data, you're not going to be able on a free plan be able to like pull all of the historical data from the node provider like Alchemy or Infura that provides an API to raw blockchain data. For that, you'd want to use an analyst tool like Dune, which is just a lot better for this use case.
This might be better for the Kaggle one because recently I use a Kaggle one and it starts to run slow and slow. 1 year ago it was pretty fast.
Yeah, and I mean it only gets slower over time because you've just got bloat of like every single day Dune ingests like a few terabytes or something of new blockchain data, like new transactions that people have made across like 6 different chains. And I mean, they've got a pretty performant infrastructure for allowing us to like, interact with that data pretty fast still. But, other services that aren't optimized for that, like will probably degrade over time in terms of the user experience. So yeah, we're just really lucky to have them. So let's take a look at what's happening right here. This is this is kind of similar to a previous example that we looked at, which is still running because, oh my God, that's slow. But similar to that previous example, it's using a union to connect 2 queries where we look at, for token A, how many times was that sold on 1inch in this case, and what was the amount in US dollars of that token that was sold. And another query that's like, okay, for these tokens, when these tokens were bought, how much were they bought, and kind of combining those two together. So you can make a big table of all of these events where a token was bought or sold on a DEX in the past day. We should add that in there and just copy paste it into a new bit. Let me grab that. Please let this not take forever. I see what happened. Yeah, so this is looking at for each token. In this case, if it's token A, might be remembering this wrong, it'll be fine. If it's token A, then it's being bought, how much of it was bought. If it's token B, it's being sold, how much of it was sold. Just kind of compiling all of those events. Let's see how long that actually takes to go. But we can kind of compile all that information in a pretty awesome way. I think this is like one last SQL concept that we'll be introducing today is conditional statements. So, you know, if you are writing JavaScript or Python or whatever, you can make an if statement of if this, then that. This is the equivalent of that in SQL. You can say that in the case when there's some condition, give me this output, and if there's some other condition, give me that output. Oh, this worked. So yeah, this was the table I was talking about before. Every time a token in this, you can see ETH, USDC, whatever it was bought. It was bought for that much, it was sold for that much, just all this information over the past day. But yeah, back to conditional statements. You can use a conditional statement to do all sorts of funny things that you'd usually do with an if statement in other languages. So in this example right here, we can count, you know, from some query that we've made, all of the cases where the amount of the token that was traded was not 0. Can count that using a case. Skip that. Yeah, this is a more interesting thing. This is you know, a kind of a more complicated query where we can do a lot of work of give us all the cases where the amount in US dollars is greater than 0, because that's a buy event for that token. If it's less than 0, it's a sell event. Let's count all of the, what's the word, distinct trader addresses, count the number of buyers, count the number of sellers, and kind of all of this interesting stuff in one really big query. The thing that was taking forever before finally finished, and I can barely remember what it was for now. What was this for again? Yeah, this took forever, but this was that query we were looking at before in terms of what's the balance of who holds the most of a certain token. But yeah, I think that this kind of bigger query at the end here that uses conditional statements is an interesting one. I can show that. I realize actually that it's 7:10 now. I never asked before how much time we've got for this session, so I might, you know, kind of speed to the end probably. What was the mistake here? This was the mistake. Might be this the Dune V2 thing. Anyway, yeah, that was kind of some simple concepts explained best as I could. You can definitely come up and ask any questions about that afterwards, about decentralized exchanges, how you can look at their data on Dune. And yeah, I think it looks like in your next session, you'll be looking more at NFT stuff, which is always fun. And thanks for coming, guys. It was nice meeting you all. Yeah. What's the plan, Imran? What's the
coming in 5 minutes.
Pizza's coming in 5 minutes. Yeah. So yeah, if you've got any questions about Dune or about venture capital in crypto or about any other random thing I can help with, I'll try and do that.
I just want to ask if the